Before we start with the specific motor pathways, I want to make sure that we all know what I mean by pathways. So we've been talking about different regions of the brain and their functions. And of course, that's oversimplified because brain regions all communicate with each other, and that's what allows us to function. But we have to be able to talk about functions of brain regions if we want to learn about them. And you've also learned about neural communication, right? So that was not all for nothing. That's a neural pathway, right? So if you've got a cell body of a neuron and then an axon that's talking to another neuron, that could be in one brain region, and this could be in another brain region. And that's then going to be a pathway. Maybe this is another neuron that connects out to, obviously, a skeletal muscle to allow it to contract. This would be a motor pathway, and that's actually what we're going to be looking at starting in the next video. But I want to give you an example here with what some brain regions we've seen before and kind of simplified. So if you remember, we talked about the basal ganglia or the basal nuclei. We're going to see them again with motor, but these three here are our basal gang. I'm going to call them basal nuclei. Same thing, basal ganglia. And they are going to receive projections from another brain region that you've learned about. Remember, these are involved in motor. They're going to receive information from the substantia nigra, which is in the midbrain. So this here is a frontal section, a slice through here. This is the midbrain, which is part of your brainstem, right? So this is much more both posterior and caudal, and actually inferior because of the turn of the brain. And the substantia nigra is this black substance right here that is full of dopamine, which is a neurotransmitter. These cell bodies that are full of dopamine are going to talk to the neurons up here. So I'm going to make my pointer a little smaller here and try to draw that in. Here is a bunch of cell bodies, right? That's what all that black stuff is. It's not always black, but with dopamine, it is. In this case, very dense. And those cell bodies project to the striatum. So here we're going to have some axon terminals, synaptic terminals, etc. Not the most beautiful picture. Here is a very simplified image of what that looks like with a diagram, right? You've got the substantia nigra that is producing dopamine and releasing that dopamine as a neurotransmitter from its synaptic, from the synaptic terminals into the striatum. So if this is the striatum down here, I'm going to read that. Here's our striatum. Actually, I'm sorry, I'm going to do that in purple. So the striatum is going to be purple. Substantia nigra, I'll draw first. It's going to have cell bodies full of neurotransmitter that it releases into the striatum. This is our striatum. These boxes represent, I'm sorry, I didn't draw that low enough because it's actually going to go into the striatum. The boxes represent brain nuclei. This is then going to go off somewhere else, have some processing. We have projections, maybe divergent projections, both to the cortex as well as within the striatum, etc. That's not really the point. The point is this projection right here. This is a piece of a pathway. So we'll be looking at some motor pathways in one direction, meaning from primary motor cortex, for example, to some other midbrain brainstem nuclei down to the skeletal muscles to produce a motor movement. In reality, there's also sub-processing and convergence and divergence of different types of neurotransmitters on different types of receptors that's always happening that we're not going to go into all of course. No one knows all of it, which is so cool.